Hello grade 12. So this is chapter 6, page 157. We will explain what is a weak acid and a weak base. If you recall, in the previous chapter, we have defined a strong acid, a species that dissociates completely into H3O+. This is why, if you remember, concentration of H3O+ will be equal to the concentration of the acid in the case that we are dealing with monoacids. So, in general, an acid, according to Bronsted theory, is any species capable of donating a proton. A proton, it means H+, or H3O+, because H+ is just made of a proton. So hydrogen, I think you know that, so hydrogen is made of one proton in the nucleus and one electron. If it loses the electron, so it becomes the cation H+, and what is left is only the proton. This is why when we say proton, it's H+, or H3O+, because H+ in water, it attaches to H2O to become H3O+. So an acid gives, donating or giving H3O+. So H3O+ is the product. A base, on the other hand, is any chemical species capable of accepting a proton. So a base accepts a proton, H+ or H3O+, and gives Hb, for example. Okay? So H+ will be in the reactants. An acid is a weak acid when its reaction is partial, not limited. So Ha plus H2O, instead of a total reaction, we have a partial or limited reaction. It gives A- plus H3O+, because the Ha will lose H and what is left is A-. In weak acid solutions, the concentration of H3O+ will be less than the initial intended concentration of the acid. They will not be equal because the dissociation is not complete. And the pH will be more than minus log Ca. It means less acidity. So a base B- is called weak base when its reaction with water is also partial. B- or A- in any species here, now we call it a base, and we will see it's called the conjugate base, because when the H, the proton, leaves the acid Ha, what is left is called a base, a conjugate base. So, in a reaction with water, it dissociates incompletely, partially, to give HO- and BH. So H2O, it will dissociate into H+, that will be attached to B- and HO-, and the reaction gives a basic solution in the presence of HO-. However, the concentration of HO- will be less than the intended or initial concentration of the base, and the pH will be less than 14 plus log Cb. So if you remember, this is the formula that we used to find the pH from a strong base. So if we had a strong base, كنا نقول pH equal 14 plus log Cb. However, in this case, because it's weak, so the pH will be less than this number. It's less basic. The degree of dissociation alpha of a weak acid is equal to the ratio fraction of the amount of acid dissociated to the amount of acid initially present. يعني, in this reaction, we had Ca, an initial concentration. However, the concentration of H3O+ is equal to the concentration of Ha that dissociated. So H3O+ or Ha dissociated, this is the concentration that becomes H3O+ over Ca, so this is alpha, we call it the degree of dissociation. Finally, for today, a conjugate acid-base pair is constituted of two conjugate species that exchange a proton. According to the relation, acid gives base plus H plus, so HA is the acid, A minus is the base, conjugate base, and H plus is the proton. For more examples and information, please read this chapter. Okay, do not just study this conclusion. And next week, hopefully, we'll continue this chapter.